Here we have a linked list, and each node contains an integer and a pointer to the next node. And I'm going to remind you, since this is your first week of doing linked lists, that pointer means it has the address where you can find the next node. Here, head has the address where you can find the first node. So we're going to practice deleting from a list. We're going to delete the node that contains a particular integer. So it could be the one with a 4 in it, the one with a 7 in it, the one with 11 in it, etc. With linked lists, it's often easier to deal with the special case of the head first. So if we say we want to delete the 4, what should we do? Well, this is easy. We make head point to the next one in the list and not this one. Now we say we've deleted it. In truth, it's still there, just as everything is still in memory, even though we think we've deleted it, until something else is written on top of it. So yes, this first node is there and it's still pointing to the next one. However, there's no way I can get to that first node because head has the address of the second node here, the one with the 1 in it, and I do not have a pointer that's pointing to that first node, so I cannot get back to it. To all intents and purposes, it is no longer there. If I wanted to delete this pointer, then I would probably, head was pointing to here, I would probably have to set up a temp pointer pointing to that first node. Then I can move head on, and then I can say t.next equals null, and that would make this null and no longer point to that second node. In this example, it doesn't much matter, but in some of your homeworks it may. So let's just go back to what we had before. We had this continuing to point there, but nothing pointing here. Supposing, I can almost hear some of you saying this, supposing head was the only node in the list. So now I've got head pointing to a single node. Well, what did we just say here? We said head equals head.next. That's how I move it on. And that's all I have to do. Head equals head.next. Okay, what about this? If I say head equals head.next, head.next is actually null. So now head is null, which is the definition of an empty list, which is correct. It only had 1 in it to start with, and I just got rid of it. So whether we have only one node in a list, or we have a list of several nodes, the way that I delete the first node is to say head equals head.next, and that points it to the next one in the list, and I am done. Well, that was a special case where we wanted to delete the node that was at the head of the list. Suppose that's not so. Supposing I wanted to delete the one with the 7 in it. I have to get a pointer to move along this list, but I need to stop before the node that I want to delete. So I start with current pointing to head, and then while the item in currents next is not the one I'm looking for, I move current along. And at this point, the item in currents next is the one I'm looking for, and so I will stop here. So now I have the node before the one I want to delete. And what I need to do is to hook this up. I want to take this one and make it point here and not to the next one, effectively eliminating this node. So at this point, I want to say current.next is, because it's current.next, it's going to be changed, no longer point here, but point someplace else. It's current.next. Because if current points here, current.next points here, and current.next points here. So this one is current.next. So I need currents next to point to current.next. And once I've done that, it no longer points there, and so my list is 4, 1, 11. The other special case, let me put this list back as it was before. The other special case is what happens if it's the end of the list that needs to be deleted, the 11. Well, current is going to move along until it gets to the node in front of the one that we want to delete. And then let's see if this piece of code works. Current.next equals current.next. Well, current.next is this node, and this node's .next is null. So this is the same as saying current.next is null, which would do this, which is what you want. We just eliminated the node with the 11 in it. So let's look at some code. And the first thing that I had to do here was set up a list. And I did it by putting my integers into an array, just so that I don't have to keep on typing from the keyboard, although we certainly could. And so I've got my head as a special case. I'm going to take the 67. I'm going to put that into a node pointed to by head, and I'm going to have tail also pointing to head. And now for the next 4 numbers, I'm going to make myself a new node with an integer in it. The tails next points to this new node, and then tail is the new node. So just to go over that piece of code again, you take the first number, whether it's in an array or from the keyboard, you take your first number, you put it in a new node pointed to by head. and you make tail also equal head. Then 4 times you make a new node pointed to by temp. Here is my new node pointed to by temp. New node always gets a null as its next pointer. Then tail.next is temp. This is tail. Tail.next is temp. And then tail is temp. So tail now points here. Head, I will not move. Do this one more time. So temp now points to my new node here. Tail.next, tail is this one. Tail.next is this. This now points to this new node, my temp, and tail equals temp. So tail is not going to point there. Tail is going to point instead here. And you can see how this goes for the others. So I am building my list. Head is going to point to the first one. Tail is always going to point to the last one. Once I have created my list, I'm going to print it out just to check that it has the numbers in that I thought it had, or that it should have. I put a loop in here and I put a note here, uncomment lines 31, 32, and then the end of the for loop, and that will make a for loop so that you can delete all nodes. I should say all. Delete all nodes in the list. But just now going to do one. What's the integer in the node you want to delete? Take in some value, and then again check our special case. If it's the item in the head, then I'm going to move head on, head equals head.next. Otherwise, start current at head, and here is my entire while loop, lines 45 and 46, while, and I have to cast it, while current's next item is not the number I'm looking for, move current on. And then once I'm out of that loop, current points to the node before the one that's going to be deleted, and here is my piece of code that I wrote on my sketch pad, and then print out my new list. Let's see how this works. So here is our list. What do you want to delete? Let's try the head, 67, and our new list is everything except for the head. Let's run it again. Let's delete the tail, 12. And here is our list without the 12. And pick one in the middle, 45. And here it is without the 45. And if I uncomment them, I don't want to waste your time here, but if you uncomment them, you can do this 5 times and you can eventually get down to an empty list. You know the list is empty because when it prints it, it'll say new list is, and then nothing after it, and that's because there's nothing to print. Okay, download this and play with it and make sure that you understand it.